And this one is for Engage New York, Eureka Math, Module 1, Lesson 3. Equivalent ratios in this one. We're going to learn how to solve ratio problems by finding equivalent ratios. You'll be successful today if you can identify the missing value. So we're going to look on finding that missing value, finding the value. We're going to do it in two different ways. We're going to be using a tape diagram and using multiplication, which is we call a giant 1. We're going to use both those methods in solving these problems. We're going to look at the exercises 3 and 4 in this particular video. So let's go ahead and look at it. Okay, so our first problem is here. Mason and Laney ran laps to train for a long-distance running team. The ratio of the laps that Mason ran to the number of laps that Laney ran was 2 to 3. So again, whenever you're doing these, make sure you really identify. So we're talking about Mason and Laney. So that lap is 2 to 3. So if Mason ran 4 miles, how many laps did Laney run? So they want us to draw a tape diagram, and we're going to use the tape diagram, like I said, to solve these. We're also going to look at other methods. So let's go ahead. When we draw a tape diagram, we're going to represent the ratio. So our first one, so since it's Mason to Laney, so we're going to put an M here to represent Mason. And that tape diagram is, when we draw these, we draw 2 to represent the 2 parts. You can call these bins, boxes, whatever you want, but it's going to have 2 parts. And then Laney, since the ratio is 2 to 3, his is going to have 3 parts. Now these don't have to be drawn perfectly, but you do need to realize these parts all represent the same amount. And that's important with ratios, is these parts here are all the same amount, and that's what's going to help us solve these problems. So then we go on. So we've represented the ratio with a tape diagram. Then we go on. So if Mason ran 4 miles, how far did Laney run? So we know that this chunk right here, because that's what Mason did, represents 4 miles. Okay, so that's 4 miles. So since it took 2 chunks of that to make that, we know each one of these is 2. Okay, since each one of those is 2, and these are all the same pieces, that tells us this is 2. So we end up with this being 6. So we know that Laney ended up running 6. So that's using tape diagrams. So we divided the 4 by the number of pieces, 2, and that gave us 2. Now the other way we can solve this is with by using multiplication, in which we write the ratio as a fraction. We talked about writing the ratios with the word 2 or with a colon, but when we want to use multiplication, we write them as a fraction. So we're going to write, again, the same thing here. And we know that was 2, 2, 3, wasn't it? What we're going to do is we're going to find what we call a giant 1. So something we can multiply both these by, so we get an equivalent fraction, because that's our goal, is to get equivalent fraction, because we know that will be an equivalent ratio, to what we know. We know the part we have is 4. And the missing part down here is what we got to figure out. And we just ask ourselves, what do we times 2 by to get to 4? In this case, it's 2. The reason we call this a giant 1 is because we're multiplying by 1, so it has to be 2 over 2, or 3 over 3, or 4 over 4, whatever it is. Whatever we multiply the top by, we have to multiply the bottom by. So this is just finding equivalent fractions like you've done before. So 2 times 2 is 4, 3 times 2 is 6. So that's that method using multiplication. So with both those, we ended up with Laney running 6 miles. Okay, so we're either using multiplication or a tape diagram. And they often call this description rule in the next lesson, but we're going to call it multiplication. So let's go ahead and look at the next situation. So again, our ratio stays the same, but in this case, Laney ran 930 miles. So let's again start by drawing out our tape diagram. So we have our Masons and Laney's. But in this case, they tell us how much that Laney did. So we know that these three pieces are equal to 930. Now, you might be able to figure that out, but if you can't, what we can do is we can take that and we need to divide it by 3. So let's take the 930. We're going to divide that by 3. So that goes in there 3 times 9, minus that down. Get a 0, drop our 3 down. 3, it's going to go in there 1 time. 3, minus that down. We have to keep going because we do have a 0 there. So we get a 0 and a 0. Have to bring our 0 down. How many times does 3 go into 0? 0 times. So we end up with 310. So that tells us each one of these is 310. We don't have to fill them in. If you want to, you can write in there. But since these are all the same size, that tells us this is 310. So since there's 2 of them, this size right here, Mason's is equal to 310 times 2 because there's 2 of them, which would give us 620. So again, that's using a tape diagram to figure it out. You can figure out what the size of it is. And we can use, again, our multiplication method using our giant 1. So again, we have our 2 to 3. We're going to multiply that by some giant 1, which is some number over itself. In this case, we need to get 930 on the bottom. Now, if you didn't know what that was, it's the same thing. We would have to take 930 and divide it by 3 to figure out what goes in, what we times 3 by to get 930. And that is 310. We already figured it out. So it's 310 and 310 that we times both those by. And so we end up with 620 is what we multiply both those by. So again, multiplication method or the other method there. So then our last thing is what ratios can we say it's equivalent to? So 2/3, we just showed that it's equivalent to the ratio of 4 to 6. And we showed it was equivalent to the ratio of 620 to 930. We just justified that it was equivalent to both those ratios. So that's what we are doing with those. Okay, let's go ahead and on to exercise 4. So in exercise 4, Josie took a long multiple choice and the end of the year vocabulary test. The ratio of the number of problems Josie got incorrect to the number of problems she got correct was 2 to 9. So that's, again, so we have the ratio is incorrect to correct. So incorrect, again, is 2. And correct is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I just like to draw my boxes out there like that. Make sure I have them all in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that is correct. So if Josie missed 8 questions, so again, this is the incorrect. What she missed, we know that is 8. So that is 8 there. So if we divide 8 by 2, that means each box is just 4, isn't it? That means each one of these boxes, again, these bins or boxes are the same size. So that means this one is equal to 9 times 4, which would give us 36. So that's what we end up with on that one, using the tape diagram. Using our ratio, we have 2 to 9. Again, incorrect to correct. We know that she had over here 8 correct, and we ask ourselves, what do we multiply by? What do we multiply by to get 2 times what is 8? We know that's 4. So 4, and we end up with 4 times 9 is 36. Okay? So if Josie missed 20 questions, how did she get correct? Again, I'm not going to worry about the diagram here. We're just going to go in for time. Let's just use our thing here. So 2 to 9, you do the diagram on your own. It'd be the same diagram, except for you just have 20 above because it's missed on both those. So we got to ask ourselves, what do we times 2 by to get to 20? And that is just 10. So our giant one we are using is 10. And we end up with 90. So again, what ratios? We know that 8 to 36 is, and we know that 20 to 90 is equivalent to that. Okay, so either one of those will work. Now this one does go on to the next page, and adds keeps going there. So let's go ahead on the next page, come up with any other possible ratios. So again, we started with 2 to 9. So 2 to 9, just like equivalent fractions, we can multiply that by anything. So I'm just going to give you one. We could just say 3 over 3, and that would give us 6 to 27. So that's another one. So any giant one here will work. How do you find those numbers? Again, we're just multiplying. The key is we're multiplying them by the same thing. We multiply the numerator and denominator by the same thing. Make sure you write something down here in your book in both these. Okay, describe how to create equivalent ratios. Take some notes here because this is the key thing. We can use the tape diagrams, and if you like the tape diagrams, you can keep using them. But eventually we want to go to just this multiplication method where we're using it because that's going to be our most efficient way. Okay? All right, good luck with this video. Let me know if you have any questions. Have a good day. Bye.